So we are starting a new chapter, linear inequalities. Everything in mathematics is not an equation. Sometimes we need inequalities as well. And let us try to understand how inequalities might arise from a real situation with this example. Ravi goes to market with 200 rupees to buy rice, and rice is only available in packets of 1 kilogram. I did not write those details, but what is important is that each such packet costs 30 rupees. So if he buys X such packets, if he manages to buy X such packets, then the total cost will be 30x rupees, but he has only 200 rupees available for spending. So that is why 30x should not exceed 200. We should have written less than or equal to 200, but because x is a whole number, x is the number of packets, and you cannot make 30x equal to 200, so strict inequality has been kept. 30x cannot be made equal to 200 because 200 divided by 30 is not an integer, that is why. So you see that from a real situation an inequality has arisen. Let us see another example of that type. This time Reshma has 120 rupees for spending and she wants to buy notebooks and pens. Each notebook costs 40 rupees and each pen costs 20 rupees. So if she buys X notebooks, then the total cost will be 40x. And additionally, if she also buys Y pens, then the total cost for those pens will be 20y. So the total cost, the grand total will be 40x plus 20y rupees. But she has only 120 rupees available with her for spending, so that is why this total cost should not exceed 120. It should be less than or equal to 120. Note that this time we are not straight away writing less than, because there is no way of ruling out equality. Maybe we have equality for some values of x and y. So again you are getting an inequality here. It is not an equation. Do you see one difference between this one and the previous one, 20x less than, it was not 20x, right? 30x, I think, yeah, 30x less than 200. The difference is that in the previous inequality there was only one variable, x. Here, however, you have two variables, x and y. It can happen. In fact, the number of variables should not stay confined to 2. It can be any number of variables depending on the situation. Why linear inequalities though? That is because all the variables will appear to their first power. You saw x in the previous one. You are seeing x and y here, but you won't see x squared or x cubed. Of course, inequalities like that also are there, but we are not going to consider them here. For us, whatever inequalities we will consider, they will be linear inequalities. No square, no cube, no higher powers. Whatever variables we are having, they will occur to their first degree. If you have another variable as z, that will also appear as simply z. Next, we have algebraic solutions of linear inequalities in one variable and their graphical representation. We have seen this inequality, for example, which has one variable, which arises from Ravi buying packets of rice, and that other inequality which has two variables. The ones which have more than one variable, we will consider them afterwards because they are naturally more complicated. So now the question is this. Say you have this inequality and you ask yourself what the possible values of x are. In other words, you want to solve this inequality. Just like you solve an equation and find values of x, solving an inequality means finding those values of x that will satisfy the inequality. So what would you have done if you had an equation here, say 30x equal to 200? You would have divided both sides by 30, so that way you would have found x. Now the rules for equations, manipulating equations, One of those rules allows you to do that. Do we have similar rules for manipulating inequalities? Yes, we have. But at this preliminary stage, say we don't know of any such rule, and we still want to know what x can possibly be. So the best then we can do is, we can try some values of x and see if they satisfy this inequality. Because our aim is to keep 30x less than 200, so we will naturally start with small values of x and then only go to larger values and see how far we can go. Also, do not forget that x is the number of packets that Ravi bought. So x cannot be negative. X also cannot be a fraction. X can be 0 if he decides to buy nothing. Say he changed his mind and he does not buy any packet of rice. X can be 0 or x can be a positive integer. So let's start with the 0 value. If x is 0, obviously the left hand side is 0. 0 is less than 200, okay. So x equal to 0 is one possible value of x. X equal to 1 is also okay, because then the left hand side will be 30. 30 is less than 200. 30 times 2 is 60, which is also okay. 30 times 3 is 90, okay. 30 times 4 is 120, okay. 30 times 5 is 150, that is also okay. 30 times 6 is 180, that is also okay, because that's less than 200. 30 times 7, however, is 210. 210 is not less than 200. It is greater than 200, and you can understand that if you take higher values of x, you are only going to get larger and larger values. So you have to stop at x equal to 6. So let me write the possible values of x. So the possible values of x are these non-negative integers starting from 0 and ending at 6. These are called the solutions of this inequality, and if you write these values as a set, if you gather them and make a set out of them, that set is called its solution set. Whose solution set? This inequality's solution set. So looking at how we found these solutions, you quickly realize that this is a highly impractical way of just simply seeing which values of x might work and that way finding all the possible values of x. If your inequality is really, if it has really large numbers, then this procedure will take a very long time. So obviously we are going to need rules for manipulating inequalities so that we can solve them efficiently. So next let us see such rules. So this is the first rule. Actually there are other parts of this rule. Effectively there are two rules. One involving addition, how addition interacts with inequalities, and the other involving multiplication, how that interacts with inequalities. But there are several versions. So we start by taking any three real numbers a, b and c. They may be distinct, some of them may be equal, anything can happen. Then we have these following implications. The implications are read like this. If a is less than b, then a plus c is less than b plus c. That is, if you have an inequality of this type, you can add any real number to both sides, just like you can add a real number to both sides of an equation, just like that. The exact same rule here, only the difference is that now you have inequality. Also note that if you have less than here, you have less than here as well after adding c. Similarly, if a is less than or equal to b, then a plus c is less than or equal to b plus c. Very easy. You just add c to both sides and keep everything else as they are. And then if a is greater than b, there is no real need to write these two separately, but just for the sake of our convenience, I have written it like this. Why? That is because you can write a greater than b as b less than a. So then it's just like that one. But anyway, let's see how it looks. If a is greater than b, then a plus c is greater than b plus c. That's it. Whereas if a is greater than or equal to b, then a plus c is greater than or equal to b plus c. So just like you can add any real number to both sides of an inequality without changing its type or direction, you can also subtract the same real number from both sides. If a is less than b, then a minus c is less than b minus c. In fact, this rule is actually included in the previous one, because you can just replace c with minus c. There c was any real number, so you can add minus c to both sides to have this from the previous one. And similarly you have the others as well. So that's how subtraction has also been involved here, which in a sense is just addition. And next we have rule 2, which involves multiplication. Again we are considering three real numbers a, b and c, but now there is a condition on c. C is greater than 0, c is positive, c is not 0, c is not negative, c is positive. Then you can just simply multiply both sides by c without changing anything else with the inequalities. But if you go into the specifics, this is how they look. If a is less than b, then ac is less than bc. That's it. Originally you had this, you just wrote c on both sides, keeping everything else intact. If a is less than or equal to b, then ac is less than or equal to bc. If a is greater than b, then ac is greater than bc. And if a is greater than or equal to b, then ac is greater than or equal to bc. Again, re-emphasizing the fact that for all this to happen, c needs to be greater than 0. Now what will happen if c is less than 0? If instead c is less than 0, then also you are multiplying both sides by c, so that you will have ac here and bc here, but now the inequality will get reversed. If it is like this, it will be like this now. It looks like an arrowhead, right? And the arrowhead was pointing towards a. Now it will point towards that side. If a is less than or equal to b, now ac will be greater than or equal to bc. You can express all these things in one sentence like this. When you multiply both sides of an inequality by a negative real number, the inequality gets reversed. That's it. There is a chance of making a terrible mistake here. You do exactly one of these two things. Either you keep the sides on which a and b lie intact, so that if a is there and b is here, you continue to write a there and b here, and with them you write c and you reverse the direction of the inequality. Or you interchange the places of a and b, but then you keep the inequality just like that. In other words, instead of writing this, you can write this also. So you keep the inequality like this. Now b will come with c, but on that side, and a will come with c on this side. Same thing, ac greater than b, this one is also ac greater than bc, sorry, and this one is ac greater than bc. Do not mix them up, okay, then everything will go wrong. So basically that's just it. These are the two rules. You can talk about division, but division, like subtraction is ultimately addition, division is also ultimately multiplication. So if you are dividing both sides of an inequality by a positive number, then actually you are multiplying both sides by its reciprocal, which is also again a positive real number. So those rules the ones that we wrote before these ones, they will apply. But if your C is a negative real number and you are dividing both sides by C, then you are multiplying both sides by 1 divided by C, which is also negative, then all these inequalities getting reversed, they will apply. Armed with these rules, we now go back to that Ravi inequality, 30x less than 200, and we ask these two questions. Questions means we have to solve this inequality when x is a natural number under this condition and then x is an integer. So you note that here x has to be positive because natural numbers are positive integers. Here, however, x can be negative, so the solutions will differ. So obviously we start with the given inequality and then we divide both sides by 30, which you can also view as multiplying both sides by 1 divided by 30, which is our C now, and that is positive. So that is why the inequality maintained its direction. It did not get reversed. Then after cancelling these two 30s, the left hand side becomes x. Here also, after some simplification, you have 20 divided by 3, which is 6 point something. So from this you get a clear and a better idea than before, simply just trying to find x by seeing which values were much better than that. Here you know that your x has to be less than 6 point something. Now you don't really need to know this something, because anyway you want the solution. In one case you want them as positive integers, in the other case you want them as integers. So the largest integer that is less than 20 divided by 3 is 6, and that is why if you want your solutions to be positive integers, natural numbers, then these are the solutions. Whereas if you want your solutions to be integers, then you can include 0 and all the negative numbers as well, because all of them are less than 20 divided by 3. So that's how in these two cases you get two solution sets. This one is a finite set, but this one is an infinite solution set. Next we have this example where the inequality to be solved is 5x minus 3 less than 3x plus 1. It's not that every inequality has to come from a real situation. Sometimes you can just simply consider a mathematical inequality, and we have to solve it for x in these two cases. In the first one, x is an integer, and in the second one, x is a real number. So in this second case, there is actually no restriction on x. So we start with the inequality 5x minus 3 less than 3x plus 1. Then what we first do, we subtract 3x from both sides. So 5x minus 3 minus 3x less than 3x plus 1 minus 3x. This we can do by one of the rules in part 1. Part 1 means rule 1. So 5x minus 3x is 2x, and minus 3 of course remains, and here 3x minus 3x is 0, so only 1 remains on the right hand side. In the next step we add 3 to both sides, again by one of the rules in rule 1, so that gives us this. Now the left hand side becomes 2x and the right hand side becomes 4. And then we divide both sides by 2, because 2 is positive, the inequality maintains its direction, it does not get reversed. And then after cancellation, this side becomes x and this side becomes 2. So x needs to be less than 2. Obviously, while actually solving such inequality, you won't show all the steps like this. But I have shown things in detail because you can see how each rule has been used. You need to see this at least once or twice. Then you can afford to not write everything like this. You can suppress some of the things. So x needs to be less than 2. And what is the condition in part 1? X is an integer. So we just have all the integers less than 2 here in the solution set. So all the negative integers and 0 and 1, and that's it. And in part 2 there is no restriction on x, so x is any real number less than 2, and the set of all such real numbers you know is this interval minus infinity comma 2, open interval. Open on the side of minus infinity, of course, always. Open on the side of 2 as well, because x needs to be strictly less than 2. 2 is not one of the values of x. The next example has this inequality 4x plus 3 less than 6x plus 7, and here nothing else is said about what x should be. And when there is no restriction on x, you just have to assume that x is a real number. So this time we won't be so boring with the details, instead we do things quite quickly. So this is our inequality 4x plus 3 less than 6x plus 7. So we decide to do two steps at once. We subtract 4x from both sides. Subtracting 4x from this side will not leave anything, anything involving x. On this side we will have 6x minus 4x, but simultaneously we are also subtracting 7 from both sides. Then from this side 7 will vanish and this side will become 3 minus 7. So that's how you have this. 3 minus 7 is minus 4, 6x minus 4x is 2x. And then we divide both sides by 2. Because 2 is positive, so the inequality does not get reversed. Dividing minus 4 by 2 gives you minus 2, and dividing 2x by 2 gives you x. So x needs to be greater than minus 2. Do not just leave your answer till this. Please write this as well. So the solution set is the set of all real numbers greater than minus 2, which is just this interval, open interval minus 2 comma infinity. Oh, and one more thing. Whenever you write infinity, no, some people have a tendency of leaving it open. No, it should be closed. It should be a closed loop without any end. Next we have this example in which the inequality to solve is 5 minus 2x divided by 3 less than or equal to. This time we have less than or equal to, but of course it does not really make any difference in our solving procedure, solution procedure. That is less than or equal to x divided by 6 minus 5. The inequalities, however, are getting more and more complicated gradually. So we start with the given inequality 5 minus 2x over 3 less than or equal to x over 6 minus 5. And then to simplify things, we multiply both sides by 6. That will create cancellations and things will be simplified. And the inequality does not change direction because 6 is positive. So if you multiply this side by 6, 1, 3 and 3 will get cancelled and you will be left with 2. 2 times 5 minus 2x less than or equal to 6 times x over 6 is x. Minus 5 times 6 is 30. So this side becomes 10 minus 4x less than or equal to x minus 30. And then we added both 30 to both sides. So from this side 30 will minus 30 will vanish and this side will be 10 plus 30. And simultaneously we also added 4x to both sides. So minus 4x will vanish from this side and this side will become x plus 4x. So this becomes 40, this becomes 5x. And then we divide both sides by 5. Because 5 is positive again, the inequality will maintain its direction. 40 divided by 5 is 8 and 5x divided by 5 is x. So x needs to be greater than or equal to 8. So x needs to be greater than or equal to 8. That means the solution set will be this interval. Because 8 is included, so we write square bracket on the side of 8. Closed 8 comma open infinity. It looks like two 8s, one is standing upright, the other one is sleeping. Next example has this inequality 7x plus 3 less than 5x plus 9. But we not only have to solve this, but we need to draw the solution set. That is the graph of this inequality on the number line. So we first solve the inequality 7x plus 3 less than 5x plus 9. So 7x minus 5x less than 9 minus 3. I am not going to explain in detail the steps that we use here. It's kind of like working with equations. So 7x minus 5x is 2x and 9 minus 3 is 6. Then we divide both sides by 2. So that way you get x less than 3. And that is why the solution set consists of all the real numbers less than 3. And that makes this interval minus infinity comma 3. Now you need to draw this interval on the real line. So to draw the interval on the real line, you first draw the real line and then locate your points, whatever are relevant to show this one. For example, we need this boundary point 3. So it is all the real numbers less than 3. Geometrically, they correspond to all the points that lie on the left side of the point which corresponds to 3. But 3 is not a part of the set. To indicate that fact, you draw a small circle at the location where you have 3. And then to indicate that we mean all the real numbers that lie on this side, you make this side of the axis or real line, same thing, bold. Okay, you draw it a little bolder, a little thicker than your usual real line. So that is the graph of this solution set. And let me just end the video here itself. There are a few other examples after which the exercises will start. So we will do these things in the next video on this topic. So see you in the next video. Until then, this is me, Lucifer from A Mathematical Room. Have a nice day.